You flip a fair coin 4 times. Which of the following is more likely? They have all 4 heads, or tails, heads, heads, tails? What do you think? A or B? Or, darn trick questions, they're the same odds. Now, why is that? Well, first we should figure out how many different things can happen if you're flipping a coin 4 times. And we can use a tree diagram to help us look at this. After the first flip, you have heads or tails. And there's a 50% chance of either. And then you flip again, heads or tails. And then you flip again, heads, tails, heads, tails, heads, tails, heads, tails. And then you flip one final time. And each branching point has the same odds, 50%, 50%, 50%. This is not a very efficient way of doing this. So there are 2 to the 4 outcomes. And that's 2 times 2 times 2 times 2 is 16. So the size of our sample space is 16. There are 16 things. Now the case where you get 4 heads in a row, that corresponds to this sequence of events. In the case where you have tails, heads, heads, tails, that corresponds to this sequence of events. Now, all of these outcomes are equally likely. Let's think about this in terms of the multiplication rule. The odds of the first coin being heads is 1/2. The odds of the second coin being heads is 1/2. The odds of the third flip being heads is 1/2. The odds of the fourth being heads is 1/2. This ends up being 1/16. And all that tells us is the same thing doing this sample space tells us. There's 1 outcome over 16 possible. There's 1 outcome with all heads over 16 possible outcomes. But notice that this is the same way we would figure out what are the odds of getting tails, then heads, then heads, then tails. Well, the odds of getting tails is 1/2. The odds of then getting heads is 1/2. The odds of then getting heads is 1/2. And the odds of getting tails is 1/2. All of these are equally likely, even though some seem more extraordinary. They're not. Here's a sample space written out. And again, there's only one case where it's all heads. There's only one case where it's THHT. So these are the 2 that we're looking at, A and B. Now, why does it seem less likely to get 4 heads in a row than this? Again, it boils down to our language. The question we tend to be thinking about is something more like this. You flip a fair coin 4 times, what are the odds that half of the results are heads? Things look more normal to us when they're less ordered, I suppose is what we'd say. So let's figure out this question. This question is a little different. So half heads. This is half heads and tails. 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 Of course, this one is also half heads and tails. This is half heads and tails. And so we see there are, did I get them all? I think so. So there are 5 outcomes out of 16 possible outcomes, which is close to a third. So these patterns, because they involve a 50-50 split, seem much more common to us than something which is only heads or only tails. So that's probably the reason. If you thought, back in this question, if maybe you thought this looked more natural or more probable, it looks more balanced to you, because getting a 50-50 composition of heads and tails does happen more often than all heads or all tails. Although, one more comparison here. What are the odds that they're not even? Well, if you look at all of these, excluding when it's all tails or all heads, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 outcomes where heads and tails are not even and not all H or T. So that would be 8 out of 16 would be 1/2. So half the time you should have more tails than heads, or more heads than tails. 5 out of 16, percent, about a third of the time, you should have an even split of heads and tails. And then rather less often, you should have either just heads or just tails. But the odds of any one of these happening is equal. The odds of any one of these happening is equal. Now let's make this a little less intuitive, if it wasn't already. Which is more probable? This is a trick. If I had, how many here? Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 heads, or something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So which of these is more likely? Again, they're still the same odds. It's surprising, but if you want exactly that sequence is just as frequent as this sequence here. They're both going to be 1 out of 2 to the 10, which is a pretty big number. Let's do this out. So a little review of exponents. 2 times 2 times 2 times 2 times 2 is 5, 6, 7, 8, 9, 10. All right, so 4, 8, 16, 32, 64, 128, 256, 512, 1024. So about 0.1% of the time you'll get all heads, flipping a coin 10 times in a row, but also 0.1% of the time you'll get this exact sequence. Okay?